Hello, everyone, and welcome to this Voices webinar series, Use Cases and System Integration. My name is Kevin Vita, and I'll be helping with facilitating today's webinar. This webinar is sponsored by the Federal Highway Administration and hosted by the National Operations Center of Excellence, also known as NOCO. As a quick reminder, if you don't know already, at NOCO, we offer a variety of resources to support the transportation systems management and operations community. Now I'll cover a few logistical items for today's webinar. The presentation slides will be available through the on-demand learning section of our website. All the attendees are in listen-only mode by default, but we'd like you to stay engaged by using the question and discussion pod for comments and questions. We will have a question and answer session at the end of the webinar, so if you have any questions that come to your mind during the presentation, we encourage you to enter them in the pod as they come to your mind at any time. The questions will be read out loud one at a time by the moderator, and our presenters will answer each question. So that's all I have, and with that, I'll hand it over to our moderator, Lindsay Grooms, to start us off.
Thanks, Kevin. Hi, everyone. Welcome and thank you for attending today's Voices Public Engagement webinar. My name is Lindsay Grooms. I am a communications specialist with Leidos and will be your moderator for today. First, I will introduce our speakers, Danielle Chow, Rob Heilman, and Robin LeClue. Danielle is with the Federal Highway Administration and serves as Program Manager for Emerging Technologies. Rob is with the United States Department of Transportation's Office of the Assistant Secretary for Research and Technology. He is the Director of the Highly Automated Systems Safety Center of Excellence and Program Manager for Voices. Lastly, Robin is with Leidos and serves as Project Manager for Voices. He manages the community of practice and technical development. Now let's take a look at today's agenda. It includes an introduction discussing the future of transportation, an overview of Voices, Voices use cases, system integration, the Voices schedule, and at the end, as Kevin said, there will be an opportunity to ask questions. Feel free to add any questions or comments as we go through the presentation, and we will do our best to address them at the end. And with that, I will go ahead and pass it over to Rob to discuss the meeting objectives.
Thank you very much, Lindsay, and I'd like to welcome all of you to the webinar, and thank you for your interest in the Voices program on behalf of USDOT. As Lindsay mentioned, I'm with the Office of the Secretary, in particular the Office of the Assistant Secretary for Research and Technology, who is Dr. Robert Hampshire, who is also the Chief Science Officer for USDOT. The objectives for today is to provide a pretty high-level overview of Voices, and then start to dig in a little bit into the use cases that we are exploring for this initial instantiation of the Voices platform. And then I'm going to describe our process and methodologies for systems integration and how we've developed the initial architecture. And then we'll talk a bit about the schedule, our development and demonstration schedule, and how it is we're going to perform some tech transfer. The idea here is that the Department of Transportation is seeding this capability, developing the initial instantiation, and then turning it over to industry. And then, of course, as Lindsay mentioned, address any questions that you might have. So we'll move on. I'm going to talk a little bit, starting off here, about our view of the future of the transportation system. If we can go to the next slide. This program is basically sponsored by the Office of the Secretary of Transportation, which again is where I reside within DOT. We are in a close partnership with the Federal Highway Administration because the initial instantiation of Voices is tied to surface transportation, and in particular, we're looking at cooperative driving automation. The reason that we're doing this is because, from our perspective, the transportation system, the transportation network is evolving with the convergence of all of this technology that is emerging is really changing, it's morphing the transportation system from these traditional domains that we've lived with for the last 100 years or so, the space domain, the aviation domain, and the surface domain, and with the surface domain being further segregated for us into all the things on wheels, all the things on rails, and all the things that float, then with these very hard lines that segregated those, we see it really starting to evolve into a holistic, integrated system of systems. And so what we see here in this slide is really the transportation system of our past. If you can go ahead and hit the slide here forward one more time, please. And we see that these hard lines are starting to have segregated the transportation system into these different domains, starting to evolve. So if you go to the next slide again, please. And what we are seeing now really is this ubiquitously connected, again, system of systems, where, as we see here, that the digital infrastructure and connectivity really takes center stage, where networks become the stitching of the fabric that connects this system of systems, and data becomes the lifeblood of this system of the future. And it becomes extraordinarily important then that we have a secure and resilient, secure from a cyber perspective, and resilient system of systems. And we see that all of the systems that are going to be traversing this modern, ubiquitously connected, and intelligent transportation system of the future, they will need to be interoperable. And we're going to have to evolve into these different concepts of operations in which they interact in a very cooperative manner. So we believe that we're going to have entirely new concepts of operations, which are going to drive in a very efficient system, but it's going to be paramount that these systems are, in fact, interoperable, and that the connections between these systems are secure. And so if you could go ahead and forward the slide again, please. Once again, it is going to be critically important that we take a close look and ensure that the data exchange between these systems is well managed and well tested. Go ahead and hit it one more time, please, and we'll move on through here. And it is then critically important that we test in a representative ecosystem, and that we perform that testing as early as possible in the systems engineering cycle, right? As early as possible in development. And so from our perspective, to wait until the system, whether it's an AV or even a more traditional vehicle, but it's connected in any form or fashion, which almost every vehicle is going to be in the future, or if it's a piece of infrastructure and we wait until you have bent metal and coated everything and it's out there in the real world, out there in the wild, and that is the first time that it experiences the other systems that it is going to be interfacing with, interacting with, and communicating with, then that is probably not a wise systems engineering approach. It is not efficient and it is not safe. And so our intent is to provide a test environment, a test platform that enables testing and experimentation very early in the development cycle, while protecting intellectual property in a very safe and secure manner, and in a very efficient and affordable manner, really dropping the barriers of entry and affordability and accessibility in being able to test in a representative system of systems ecosystem. So if we can move on to the next slide. So that's really what we're trying to do with voices. So it allows for collaborative experimentation and testing. Some of the challenges with this type of collaborative testing in the past is that it's pretty hard to do. You can't test for interoperability at a system of systems level with other developers, other systems that you don't own, you don't operate, right? Without necessarily having some manner, some form of interoperability at the test infrastructure level. You can't test for interoperability unless the test infrastructure is interoperable. The test methods, the simulation environment, the test instrumentation, the data analytic methodologies. And so we are trying to provide that interoperability at the test instrumentation and test environment level for you. That is the idea. And we're trying to do it in a way that is exceedingly affordable, that is essentially free. There's a fee for service potentially to be able to connect to the network and run the test, but all of the test infrastructure and all of the test tools are basically open source, or they're government owned and we just give them to you. That is the idea. So it is a very effective, simple, and affordable mechanism for this collaborative research and testing. In the past, there's been all of these silos and a multiplicity of stakeholders, be them the OEMs, the IOOs, the states, government activities, and it makes it pretty difficult to come together and agree, again, on different protocols, methodologies, middleware solutions. And so essentially this is a mechanism in which, this is why we're going to talk about our community of practice in the manner in which we bring stakeholders together and resolve all of that with a middleware solution and a network that is meant to solve all of those types of challenges. The trust and intellectual property protection, that is solved as well. Your IP is totally protected. When you get into a test, a collaborative test over this distributed network, all of the other players that are in an event driven by a common scenario, they will only see your behavior as they would see in the real world, and they only are able to see the communication that they would have with you as they would in the real world over the tactical network. All of your performance data is sent back to you over the test network, and only you. Certainly the government will never see it, and all of the other players in the distributed event will never see it. It goes back to you over a VPN, a very secure network that is a network architecture that is provided to us that is a remarkably secure network. And so all of that IP is protected. And again, we provide a collection of test tools that enables everybody then to be on an interoperable network using interoperable tools over an interoperable test infrastructure to test interoperability of your systems. Next slide, please. And so what is Voices? At this point, I'm handing it over to Danielle.
All right, thanks, Rob. So as Rob mentioned, we are trying to accomplish a lot and overcome a lot of the challenges with interoperability testing by building Voices. As Rob mentioned, Voices is fundamentally an interoperability test platform that enables us to do live distributed testing across multiple sites and potentially by multiple organizations. And in so doing, it's seeking to bridge across the public and the private sector and academia, as well as across industries, and enable all of us to do integration and interoperability testing earlier in the development cycle. So you can test a little and learn a little along the way before you try something out on a real track or real roads. I think, right now, Voice's capabilities are focused on the communications testing and the exchange of each model's ground truth state. And this is the way it has been done at DoD for over a decade. Since one of this project's top objectives has been tech transfer to the private sector, we've been really focused on making sure that the Voices test platform meets the needs of its potential end users. So shortly after this project began, we stood up a community of practice, and in a span of 14 months, we held a total of 162 outreach events with 749 potential stakeholders. The Leidos team did a fantastic job talking to a lot of people. The formal COP now includes 99 organizations, which span all sorts of interests. And we have participation from, self-driving car companies, infrastructure-owned operators, intelligent transportation system developers, and tier 1 and 2 suppliers. And then likewise, we have engaged from throughout government, and we also have a strong presence from academia and the research community. Within our community of practice, we've created essentially 3 types of working groups to make sure the Voices platform design continues to be relevant in this rapidly evolving field of intelligent transportation. The first group of working groups are the technical ones, which are investigating for us how 3 different cooperative driving automation, or CDA, how 3 different CDA use cases, platooning, eco approach and departure, and cooperative perception, might benefit from collaborative testing. The second type of working group is focused on system integration and making sure that we design and build an end-to-end test capability that works the way we expect. And the last type of working group has been focused on technology transfer. So they've been really helpful in identifying market needs and the possible governance and business models to run and maintain such a test platform. It's been really critical in helping us identify and work through what an eventual tech transfer owner would need to run the platform. Robin?
Thanks, Danielle. Hi, everyone. I'm Robin, and I'm going to talk a little bit about the 3 use cases that Danielle just mentioned and the selection process or the criteria that was used to choose them. The use cases need to be achievable by independent autonomous vehicles and have a focus on safety or energy efficiency. They need to address real-world applications in such a way that they could support a business case. As Danielle mentioned, the T2 business side of things is a focus for us. Use cases need to have a cooperative driving automation attribute of some sort that makes sense for them to be tested on a virtual platform. And finally, they need to be simple enough that they don't require a whole ton of significant development. The graphic on the right here depicts some entities that could use Voices, and it shows Voices at the center of everything. This next slide is our first use case. Platooning was selected. This fit the criteria and is a great example of a real-world application where Voices could be used to help in the development and then the testing of platooning very early on, rather than having to build vehicles, bring them somewhere on a test track, and then actually test them live together. You could use Voices to do development and testing ahead of time. This is a maneuver that's just a great example for highlighting how Voices can really come into play. And further information from SAE can be found. This is a SAE slide. The second use case that was selected is Eco Approach and Departure. This one also fit the criteria, and if anyone doesn't know what this is, it's where vehicles receive information from the traffic signal and they can plan their most economical approach for energy consumption. So instead of just driving right up to the traffic signal and stopping and waiting for it to turn green, they could kind of slow down early, and so they would never have to come to a complete stop, and just as they arrive to the intersection, the light turns green and they can proceed through. The traffic signals could also change their phase based on the vehicle approach. So if there's no one around and they see a vehicle approaching, they could turn green for them. So these are great activities to test in voices. That's why this use case was selected. The next one, the third one, is cooperative perception. And this is where vehicles can share information with each other. In this example, one vehicle can't see the pedestrian, that's that red zone, because it's blocked. Well, vehicle 2 is blocked by vehicle 1. But vehicle 1 could share information with vehicle 2 and say, hey, there's a pedestrian here. You can't see it, but I can see it. And this is where voices could come in, and you could test these kinds of use cases on the virtual platform without ever putting a pedestrian in harm's way. So all these use cases can leverage voices kind of as the common language, the common platform, the middleware that enables this collaborative development and testing real early in the stages. So use case framework. Once these use cases were selected, work was started to refine the framework for how to write them down. Behavioral competency is where the objects of the use cases were identified. Then the functional scenario is where the objects were written down in like a linguistic form. And then the logical scenario is where the objects are turned into actual parameters. And then finally, the concrete scenario, it adds actual values to the parameters. And then the test case is where all the inputs and outputs for the scenario execution are captured. And that's kind of where you would go write down what your test is going to be. So this is sort of the framework that's used to develop each of these use cases. All of the information that we've gathered from the working groups and the community of practice has been collected and can be found if anyone's interested in the finer details of each of these use cases. This next slide is using platooning as an example of this refinement. And so the top row, we can see the behavioral competency showing the objects of the use case. So signs and cones and lanes and objects. The next row is the functional scenario where everything's written down in kind of linguistic form. The next row is the logical scenario that has turned the linguistic pieces into parameters. And then the concrete scenario assigns values to the parameters. The last row is the test case, where it's kind of written out what you're going to be doing for your test. And with that, I'll hand it back to Danielle, and she can explain a little bit about high-level architecture.
Thanks, Robin. So we've talked a fair amount about the applications that the community would like to test on the Voices platform. But how does Voices itself work? Voices pulls together 3 different types of test elements, actually. The live, the constructive, and the virtual. So live elements are like the real physical elements that exist in the real physical world, like a vehicle or a real traffic controller. Constructive elements are the purely simulated components. For instance, a simulated traffic signal that exists only in a model and has no equivalent in the real world. Another example might be an AI algorithm that can be trained and tested through repeated runs on the platform. Virtual elements are the confluence of both. They are real physical elements, but they respond to simulated stimuli. So it could be a human driving a vehicle in simulation, or an electronics board running operational algorithms in response to simulated input signals. So during a test, these three types of test elements would interact through a shared scenario that would be agreed upon in advance. The participants can be in the same place or in different locations, but they'd all be testing together in real time. The participating simulations would communicate during the test through a universal software adapter called TINA, which allows different simulations to talk to each other. So in that sense, TINA is almost kind of like USB in that it enables a sort of plug and play capability. TINA stands for the Test and Training Enabling Architecture, and it is the backbone of Voices. And it is through TINA that all the text execution, management, and the data exchanges occur. TINA was developed by DoD and has been used for over a decade, so we have the benefit of their experience. And it basically enables different parties' proprietary interfaces to talk to each other without disclosing any IP. And I think Rob had mentioned that earlier. It's very important to our stakeholders that we keep their IP secure. And rather than requiring separate agreements between each combination of testing parties, once an organization creates the TINA adapter for one of its models, that model can then test with any other model that also has a TINA adapter. So it can streamline the collaboration process. TINA is available open source and automatically includes several capabilities to its users. This includes like a core set of tools and libraries that ensure all the testing parties have a shared technical understanding of the test environment and the test requirements. It also gives the users the ability to create customizable interfaces that can standardize what information is exchanged. This could help us quickly develop and mature the types of messages that we may want to use for different types of CDA applications, thereby also accelerating CDA development. So for Voices proof of concept demonstrations, we've been using the Karma suite of tools to represent CDA applications that could be tested on the platform. Karma is the US government's reference model for understanding and advancing connectivity and automation technology applications for ground transportation. Moreover, because Karma is open source, it can help us accelerate CDA development by making it more accessible to researchers and students who might not otherwise have the resources to participate and work in this field. The Karma suite includes several different tools. With Karma platform, users can leverage its models of SAE Level 3, Class A through D vehicle algorithms in either pure simulation, or they can use it to turn an instrumented real vehicle into a prototype advanced driving system. Likewise, with Karma Street, users have a launch point for developing smart infrastructure models, and Karma Cloud can be used to represent any cloud service that might interact with vehicles, infrastructure, or other road users to do cloud-based traffic management or analytics. And then finally, Karma Messenger represents the human-driven vehicles, but with the ability now to communicate with all the other elements I just described. So for now, we're using Karma as an example of a CDA application that could test on Voices, but eventually our hope is that developers will bring whatever tools they have or they find convenient to the Voices test platform. Robin?
Thanks, Danielle. Okay, so there's a lot going on in this slide, but I'll try and break it down to explain how this represents our initial demonstration. What we did was take a live vehicle here at Turner Fairbank Highway Research Center on our campus, and we had it transmit over radio waves its position. That position was received by some roadside equipment. This is sort of the left-hand side of the box. And then using one of the Karma tools that Denise mentioned, Karma Streets, we were able to take in that information. Using a TINA publisher, we're able to send the position of that live vehicle, its heading and its speed, and a bunch of information about the live car onto the center network switch here. And because this was an initial demonstration, we just used a local network, but Voices is really built to scale up from here to do distributed testing. So imagine a network with lots of nodes and lots of people all on this common Voices network. They could be doing testing together. But for us, it was just a local initial demonstration. So information from the vehicle then gets sent to this TINA subscriber and translator. The center messages are called SDOs, and they're sort of the common language that TINA uses. And the subscriber and translator converts the position information into this standard vehicle object. And that goes back out onto the network. And if anyone else was on this network, they could use that vehicle information and they would see this live vehicle. So from there, it goes into the TINA subscriber and the Carla adapter. And this is where information about that vehicle gets actually kind of injected into this Carla simulator. And this is a simulation environment that contains the digital twin of our campus map, as well as a digital twin of that live vehicle. So this is how, using Voices and a local network, you can get a live vehicle projected into the simulation. And the bottom nodes here are showing a public repository for a scenario. This scenario contains information for the use case. As we kind of described earlier, there's a scenario publisher that pushes out this information to all the TINA pieces on the network. And then the last two bits are the data collection from TINA, and this captures all the information that's going across that network so that you can post-process and work on your data later. And then the execution manager. This manager kind of does a handshake between all the TINA adapters that need to talk to one another. So it kind of sets up the test. It says, okay, you're going to publish something and you're going to subscribe to it. It sort of sets the stage, and then it kind of takes a step away, and it's done its job of handshake. So these are kind of the major components. One thing I forgot to mention was the traffic signal in the left box there. Infrastructure as well as vehicle information can go through Voices. So on campus here for our demonstration, we used the traffic signal information, and we're able to also get that as part of our digital twin map and our infrastructure in the simulation. So a bunch of boxes and lines connecting things, but hopefully that's an explanation of what the architecture looks like. And then this next slide is explaining the results. And luckily, the results were as expected, and everything worked really, really well. This top view shows the live vehicle that I was mentioning and the intersection. This is on our campus using one of our traffic cameras. And the bottom view shows the same vehicle depicted in the digital twin simulated environment, and the same intersection and sort of the digital twin simulated model. All the driving that we did live was captured and projected into the digital twin, and it really shows how putting all the pieces that we made for Voices together builds this environment where you could really do some collaborative testing, and how Voices could be used for this distributed test environment that we're after. This next slide is just another view of the dash cam. So the live vehicle is on the bottom this time, and the simulated vehicle is on top. And it further shows that they align. They're not exactly the same view, but you get the idea. In addition to the live demonstration, we also performed a tour of our facility where we covered a range of Voices topics, including an overview of our community of practice, the stakeholder engagement, universities that are involved with Voices, as well as details on the overall Voices architecture, a little bit beyond what I've just described in the last slide. And with that, I'll hand it back to Danielle to talk about the schedule.
Thanks, Robin. Yeah, so schedule. Okay, Voices plans to deliver capability really fast. The program started in 2020, and our goal is to demonstrate a proof of concept that can start being transferred to the private sector by the end of 2022. So that's the end of this year. To do that, we've been building core capabilities throughout the past couple of years and have been testing them through a series of demonstration tests that are planned also throughout this year. Each successive demonstration grows in complexity. So Demo 0 took place in late January this year with testing on a local network. And whereas like Demo 1, our next demo coming up in the next few months, is going to be focused on distributed testing across multiple locations. Future demos are going to focus on increasing the complexity of the distributed tests and will hopefully take place at some of our external partners. We are still in the process of defining those future demonstrations, as well as identifying the eventual owner of the platform so that we can seamlessly do the tech transfer and set everyone up for success. As far as upcoming webinars go, if you'd like to learn more, we've got, I think, 3 more lined up to cover our efforts on system integration, tech transfer, and the use case demonstration results. So if you're interested, check us out at https://www.transportation.gov/HASSCOE/voices. And I'll just drop it in the chat. Then you can access it more quickly. With that, I think we'll turn it back over to Rob for some closing comments.
Thank you very much, Danielle. I think we have time for some more questions in the chat pod if anybody has any. I'll ask Lindsay here in a second how much more time we have. I would just like to close in addition to thanking everybody for your time and attention. Just kind of think of this as, when I hear Robin explain what we're doing in some of those demos is like the Matrix. What we did was this blended mixed reality event where we immersed a live vehicle and signal into a virtual world. And we can do the same thing with virtual stuff, being basically sensed by some live systems. And then we can also have what we're moving towards is having virtualized systems, like hardware in a loop, software in a loop, also then being able to play into these types of mixed reality worlds. That is what we mean quite often with our term of virtual versus constructive. So that is the power of Voices, along with the distributed nature of it, where you could be anywhere basically in the world, but in our circumstances here, anywhere in the United States. So what we're going to do in our next demo, as Danielle just mentioned, but you're all together playing in this common scenario, in this common mixed reality world. So that's the intent. But really, with my closing comments, what I want to focus on is, do we accept that we are in the midst of a moment in our history where we are undergoing a period of transformation in transportation, in particular for this instantiation of Voices in surface transportation. We can debate whether or not AVs really are going to require connectivity, or when AVs will put connectivity in their critical path. We can debate whether or not and when AVs will be regulated, but I don't know if there's really that much of a debate as to whether or not the transportation ecosystem is going to get connected. I think that's pretty clear that is happening, that things are going to become more and more digital, that things are going to become more and more intelligent, and that we are, in fact, undergoing a period of change and pretty disruptive and transformational change. And it's happening within all of our careers while we are sitting in the seat, so to speak, all of us that are in this call. And so what will we do with that technology, and what are we going to do about it? And so voices is one of many, but voices is one attempt to prepare for that future. We need a place where we can get together, a safe place, a safe space, where we can bring our systems together and we can basically mash up, where we can experiment, where we can test, where we can just try stuff out. We can try different concepts of operation. We can try different wild and crazy ideas, and we can get our stuff to work. And we can do that early in development or later in the maturation of this technology. We can do that with our friends. We can do that with our competitors. But we can do it in a way that gets this stuff to work before we put it out there in the wild. And so it allows us to refine. It allows us to get better. It allows us to get this stuff out and deployed faster and cheaper. And so that is what we're trying to do. And so we appreciate you taking this journey with us. We truly appreciate the folks that are part of our community of practice that are our partners on this journey. So that is what this is about. This is about how we lead and lean into the future, and which makes it damn exciting. And so with that, I'll turn it back to Lindsay, our very capable moderator, to see if there's any further questions that we would be delighted to answer. So Lindsay, over to you.
All right, thanks, Rob. So floor is open for questions. Please use the chat pod to submit those. We've already received a couple, which is great. Here's one. How is the POC going to be made available to the private sector?
I'll take a first crack at that. Our intention is to perform a tech transfer where we're essentially going to turn the keys of the platform over to a third party, let's say, who is going to be responsible for operationalizing the platform. Now, our intent is going to be really more than a proof of concept. I like to think of it as an initial operational capability. That is, it works. It is fully functional. And so when we turn it over to this third party, then it is fully scalable. It is fully extensible. There will be a business model associated with it, and it is then available to the private sector. Then it'll be operationalized by this third party, where any entity, including private entities, will be able to connect to the network, be able to connect both physically to the network and through TINA be able to connect to that software interface as Robin had described, and then be able to conduct tests and experiments over the platform with other parties. And so we're trying to make that as frictionless and as cost efficient as possible. There'll be no cost to the software, no cost for the tools. The only costs would be for kind of runtime, right? To be able to be on the network during a test. That is the intention. And then it'll be operated by this third party that we will make some arrangement with as we perform the tech transfer. Hopefully that answers the question.
Yeah. And we do have some preliminary documentation available, I think, on a Confluence page, if people want to access that.
Yeah, yes, and that documentation is a good point, because we will have available basically playbooks, operational guides, all the documentation that's required to be able to connect, to be able to execute a test, to be able to operate the tools, and that third party that we hand these keys over to. Part of their job will be to assist, to train folks in being able to connect and play, to conduct events, to participate in events.
If I could just add a follow-on to the Confluence pages, those are currently available to our working groups and our community of practice. So if you'd like to have a look at them, they're not fully public yet, but you're more than welcome to join our community of practice, and that will give you access to all of that information at the moment.
All right, the floor is still open if there are any more questions that anyone wants to put in the chat pod. Got some more time left.
We also welcome highly technical questions because we do have our technical experts on the line here.
You guys are pretty shy. Well, there's no reason, there's no rule, Lindsay, that we have to use all the time. Oh, what metrics?
Well, yeah, we got one from Roy. What metrics are you using to monitor the growth of this activity?
I could probably field that one. It's a good question. We take metrics monthly. Largely, they're around engagement. So number of meetings, number of attendees, how many of these kinds of webinars we've done for the project over time. We've got lots of plots and graphs that kind of depict the engagement from our working groups and our community of practice. So we're really, it's attendance, and if you were to attend any of our working group sessions, you'd find that they're very well engaged. It's not just us talking about things, it's really gathering information from stakeholders and people who have an interest in voices. So hopefully that answers your questions. But yeah, largely it's due to measured by engagement and attendance.
We also have, this is a development activity, and so we are following disciplined modern software development practices using agile software development approaches. And so we have numerous metrics that are associated with that software development methodology. And so that there's tons of metrics associated with that software development activity. There is going to be metrics tied to the earlier question on latency and network performance and things of that nature. So there is performance metrics that are tied to the platform and the network, of course. Now, metrics regarding scale and growth, post deployment. That is a great question. Voices as a program officially ends after we turn the keys over from a DOT perspective, but we are discussing the manner in which we don't abandon the project after we turn the keys over. And so we are in discussions as to how we are going to maintain some degree of support and I wouldn't call it care and feeding, but the degree with which we are able to ensure continued success of the initiative. And so more to come on that. We certainly want to see it grow, and that is something that we'll be in discussions with whatever party is responsible for operationalizing the project after DOT performs a tech transfer. How about metrics regarding the demonstration architecture? How would you answer that one, Robin? I'm not sure about demonstration architecture.
Yeah, I don't know exactly what that question. I've been trying to figure out how to answer that one. Metrics regarding the demonstration architecture.
Yeah, we may need whoever asked that question to elaborate a little bit on what you mean by the demonstration architecture. I mean, for each, so a demonstration is the culmination of and we've been talking about kind of abandoning the term demo this and demo that because it makes it sound like they're just show and pony kind of stuff. I forget what's that term, but they're actually systems integration tests. We perform a systems integration test at the end of a particular set of it's like a spiral, and that's not the right term. Give me the right term, Robin, when you get through a series of software development activities. We kind of tie a bow and perform a systems integration test. The culmination of that will then go out and demonstrate it for our leadership. So really, it's a systems integration test that we will then demonstrate. And so there are, and that's a gate. It's part of a disciplined systems engineering process. And so that there are a series of metrics associated with that gate. And so there are metrics tied to that systems engineering test that have to be demonstrated as part of that test, that our systems engineer is responsible for validating, that gets presented to the systems engineer, and then to myself as the program manager to be able to pass that gate. So there are a collection of metrics tied to that. So hopefully that helps answer that question.
And I think there are probably like two types of metrics that we look at, right? One of them is like the network performance metrics of the test platform, and then there are also metrics related to the CDA application that we're testing. And we're doing kind of development on both for each of these demonstration tests or systems integration tests.
Right,
yep.
Right. Yeah. It is important to remember that this is a development effort, and we are following very disciplined software and network development practices. Let's see. Will you provide a POC demoed presentation to interested parties in the tech transfer? Go ahead.
Yeah, and I think maybe I'll field that one, which is there is a session specifically dedicated to tech transfer, but we also have another session planned to talk about the use case testing and reporting. So the proof of concept results will probably show up in the use case testing and reporting session. But yes, we're definitely excited to share that information with you all. All right, I guess there was also a question from Paulo What is your plan to benchmark the proof of concept in terms of scalability, for example, multiple participants? Robin, I think that question's for you.
Sure. Yes, we are planning multiple participants. We're going to try and execute a platoon with these multiple participants at distributed locations. So one in this state, one in another state, sort of scattered about, and they'll perform a platooning demonstration together, or a test, an integration test, if you will. And I think that's going to be our benchmark to make sure that the whole point of voice is that is the distributed nature of collaborative testing, that it actually works. So that's hopefully an answer to your question.
I'll elaborate a little bit in that we need to demonstrate that, let's say, I hate the word demonstrate, we need to prove that the capability is truly scalable. And so, as Robin mentioned, that we will have multiple participants in the test. I hate the word demo. That's really, I'm starting to dislike the word demo. It's a test. We will validate that the capability of the platform, the network, the software can perform adequately with multiple players in the test. We need to do so in a way that proves, that validates, that can not only handle the load that we put on it for those participants, that number of participants, though that also it could scale to many other participants, to a realistic test that would include what we would anticipate a much larger CDA or a much larger ecosystem representation to be. And so that is what our job is. And so while the actual test, we can't put 25, 30, 50, 100 entities, vehicles, whatever they might be, onto a particular test, we can put that many into the constructive environment, and we can probably try to get a few into the virtualized environment, and we can get a small number into the live environment. But we have to do so in a way that validates that this capability could scale to a rather significant test. And so that is our job. And it is your job, if you're and any of you out there are in the community of practice, and I see that some of you are out there that are actually in DOT, it is your job to hold us to it, to make sure that we do our job. And so it is our job to build this thing so that it is, in fact, scalable. Over.
All right, thanks, Rob. If there are no more questions, I believe we can go ahead and move on. Thank you for all of those who submitted. Rob, do you want to make any more closing remarks?
No, you guys, you kind of got your wind there and picked up some momentum and asked some damn good questions. Sorry. Appreciate those. We like to be challenged. We like these good questions, and we like to be challenged. As I said there, I got a little fired up there because this is not meant to be a show pony. This is meant to be this is a disciplined engineering program, and this is meant to be a robust capability that is provided, that should stand up and be reliable, be predictable, be scalable, be extensible, and be damn good at what it's intended to do. And so, and we expect you guys to hold us to that, and we want you to use it. And so, thank you for attending, and thank you for the good questions. And let's move
and
to
if you have any questions after today, please do, contact us directly. We'd love to hear from you.